So welcome everybody. Our talk is called It Works on My Box, Compromising Developers via Package Registry Malware. Okay, so in 2020, the SolarWinds attack sort of revealed the full potential of a cyber attack via the software supply chain. So the quick recap is it was a nation-state sponsored threat actor who was able to compromise a SolarWinds build system. And they inserted a backdoor into their Orion network management product, or monitoring product, which then got pushed out to like some 18,000 customers, including ones at like very high levels of government and industry. So that was really unfortunate. And unfortunately, just in the years since, like the headlines just pile up. We've seen an increase in the frequency and the variety of attacks via the software supply chain, including and especially the open source software supply chain. And so that's going to be the topic of our talk today. We'll take a tour of basically how threat actors weaponize the open source software supply chain. We'll look at some case studies that we've seen in our research at Datadog. And we'll also kind of take a look at who these threat actors are and how they like profit off of kind of what they're doing out there on the registries. And then we'll also tell you how you can protect yourself and your infrastructure from them as well. So quick intro, hi, I'm Ian Kretz. I'm a security researcher at Datadog working on software supply chain security.
Hi, I'm Zach Allen. I'm Director of Security Research at Datadog, and I work with Ian and all the other researchers on everything from supply chain to cloud security and threat detection.
Great, so to start, we'll just kind of give a lay of the land as we see it. How do software supply chains work, and then what are the opportunities for threat actors within them? So at a very basic level, right, a software supply chain is just a pipeline for taking source code and producing software artifacts and then distributing those to users. So we start here on the left-hand side with the source code, right? It's in GitHub somewhere. There's a developer maintaining it over time, changing it. And then when the time comes, we're going to take the source code and any of the code it depends on, and we're going to pull it into some build environment. The build environment is going to transform the inputs into some software artifact output, like an executable. And then at the end, we're going to package it with anything it needs to run, and we'll make it available via some distribution channel to users, like an app store, for example. So there's a special case of this, and it's the one we're going to be focusing on, where the end artifact is just a distribution of a software library that's intended for anyone to use, other developers, that gets published via a package registry, like NPM. And so in that case, there's actually this interesting feedback loop that can happen where the output of one supply chain becomes the input to another as a dependency. So hence this little cycle. And so we can just ask ourselves, like, what are the opportunities for threat actors here? So it turns out there are quite a lot. At the source code stage, right, we could, for the threat actor, we could try to get in a malicious change through a PR. During building and packaging, there's lots of stuff that can go wrong, right? We can try to tamper with the inputs and outputs. We could try to compromise the build environment, as in SolarWinds, or maybe like for the package registry, try to compromise the maintainer's credentials and like swap out the artifacts or something. And then finally, if we're an attacker, we could try to promulgate malicious dependencies via the registries in hopes that some unsuspecting developer will pull them into our code or pull them into their code and thereby inject malicious code into the supply chain. And it's really this last thing that we're going to be focusing on here today. Just real quick, credit to salsa.dev for this very useful graphic. So it's good to make things concrete. And so when we're talking about like packages, package registries, we really have NPM in mind, or PyPI. So this is a highly active open source package ecosystem. Here I've just pulled like the recent data for the top 10 packages. And so we're talking about hundreds of millions of downloads per week for the top packages. PyPI, it's the same story. Again, hundreds of millions of downloads for the top packages. So here's kind of the schematic of how we think about like the way the package registry facilitates producer-consumer relationships between developers. So in the middle, you've got the registry. It's hosting the packages. It's making them available to download and search, that kind of thing. On the right, we have the library developer who's like maintaining their library. They're publishing new releases to NPM, let's say. And then on the left, there's the kind of consumer developer who's searching the registry for like new packages they could use. They're like pulling them down and installing them via usually pip or npm, some kind of CLI interface to the registry. And then they're testing them out and then incorporating them into their application. And so if we put on our threat actor hats for a minute, right, this is great because it means that the attack path is identical to the normal usage path, right? If I'm threat actor, I can just publish my malicious library instead of my benign one, and it all works the same way. Up it goes to the registry, and now it's available for unsuspecting developers to use. It's worth noting that The registries are usually really good about taking packages down in the case of like a malware report, but kind of at the point of publication, they're very liberal. Like you can pretty much just publish anything you want to the registry as long as it has the format of like a valid package. So the point is there's very little barrier to entry for threat actors to do this kind of thing. So in terms of the impacts we see, it kind of boils down to 3 categories. One is credential theft. So often these threat actors target developers specifically for their API tokens, cryptographic keys, cryptocurrency wallets, basically all the lucrative things that developers have access to. Resource misuse is another big one, so your crypto miners, your bot farmers. And then finally, there's the downstream compromise. So that's more like a SolarWinds type attack where the real target of the attack is some downstream consumer of the targeted package. And then in terms of TTPs, right, if we just kind of follow the life cycle of one of these attacks, right, if you're the threat actor, the first thing you have to do is obtain your victims. So there's usually 2 ways to go about it. You could try to take over an existing package that already has users, or you could publish a new malicious package and try to attract users to it, often via something like typo squatting. Once you have a victim, you have to get code execution somehow. So depending on what your objectives are, this could be code execution in the victim application, or if you're targeting the developer, right, using some kind of install script to get install time code execution. Since we're publishing open source malware, a lot of attention goes to evading detection. So like we see a lot of code obfuscation, use of encryption, or just like simply overwhelming a small amount of malware in a lot of legit code. And then finally, the post-exploitation stuff, which is more standard, like second stage payloads, obtaining persistence, that kind of thing. Okay, so that's kind of the lay of the land. And so now what I'll do is I'll tell you about a tool we use at Datadog called GuardDog, which is kind of the secret ingredient in our continuous monitoring efforts to find malicious open source packages on the registries. So GuardDog is a command line open source CLI scanner for identifying malicious packages. So you can see here's a run of GuardDog, pointed at a package. In this case, it's an NPM package. And GuardDog is going to run a set of rule-based analyses against the target, and it's going to report kind of all the findings that it learned about the target based on the rules. Each finding is a suspicious or a potentially malicious kind of true fact about the package. And so the idea is that we can use GuardDog as this like wide net that we cast out onto the registries, and we kind of surface the packages that seem interesting from a malware point of view, and then we do kind of further analysis on them to find out which ones are really malicious. So under the hood, GuardDog has 2 kinds of analyses. One is source code analyses, so looking for malicious indicators or kind of malicious code behaviors in the source code files in the package. And then the other analyses are more qualitative, metadata-oriented, like does this package contain bundled binary executables? Is there a mismatch between like the release on the registry versus what's on GitHub, that kind of thing. So for the source code analyses, the 2 underlying technologies are SemGrep and Yara, which are static application security tools. You can think of them as like very powerful pattern matching engines. And in the case of SemGrep, the pattern matching is semantics aware. So it knows about the semantics of the source code language that it's looking at. Right, and so kind of the key idea behind GuardDog is like a SaaS tool like SemGrep, which is kind of originally intended to identify vulnerable code patterns, can just as easily be used to find suspicious or potentially malicious ones, right? So let's say in GuardDog, we want to be able to detect shady links. Well, SemGrep sets us up nicely to do that with like regex parsing and finding. If you want to do data exfiltration detection, SemGrep sets us up with taint analysis. So over the next several slides, we'll take a look at like various examples of different GuardDog rules and how we implement them using SemGrep. Okay, so the first one we'll look at is a rule to identify when a package is registering a custom install command. So this is something we see all the time for malicious packages, especially ones that target developers. Basically, there are various hooks that are provided to the developer to register a custom install action so that, for instance, when, in this case of a PyPI package, when you type pip install requests with this weird spelling, like a custom install command runs. And so this is how that's done. So if we look at this code snippet, this comes from a real malicious package that we found with GuardDog. So we see the setup function being called. This comes from the setup tools library, which is very popular in the PyPI ecosystem. And so the way this exposes a custom command hook is via this command class argument. So basically, if I point the install key of this argument to some class that implements the custom script, setup tools will run it at install time. So here it's this group install thing. And so if we actually go through and we look at the class, here's the script, which hopefully looks a little alarming. Basically, we have this encrypted payload that's being decrypted at runtime and then executed immediately. And so if we use the hard-coded key there and we decrypt the payload, we can see this is what it's actually executing. So it's calling out to some suspicious domain, pulling down a script, and then running it. Worth repeating, this all happens at install time. So by the time your pip install command is finished, like, you're already pwned. So how do we write a semgrep rule to detect this kind of thing? So here's the complete guard dog rule that we use in the real tool. It's just a simple pattern match, right? So we're looking for calls to that setup function where the command class argument has been set. And then in particular, we want to match on the install key being present. We also have develop and egg info because those govern kind of other type of installations. But it's really as simple as that. So for the next example, we'll look at something a little more complicated, a little more interesting, executing base64 encoded data. So here's another example that comes from a malicious package we found with GuardDog. You can see what's happening is basically, like, we've got this base64 encoded payload. It gets decoded, and then immediately executed. And so if we decode the payload, this is what's happening. Again, it's a downloader, so we're calling out to some domain. We are downloading like a PE executable on line 10. And then we're executing it on line 15. So if we kind of break this out, right, into its component pieces, there's kind of two pieces, right? There's the decode step and there's the execution step, right? And so base64 encoded payloads, not that weird, right? There are all kinds of legitimate use cases. I'm sorry, not payloads. Base64 encoded data being in source code is not that unusual, right? There are legitimate use cases for it. And if we tried to write a rule to detect this kind of thing based only on the presence of a base64 decode, it would be way too noisy, right? But it's really the combination of decoding the data and then passing it to exec where we start to get a little antsy, right? So we have to find a way to connect these two things, base64 encode into exec, and that's what we want to alert on. So fortunately, we have semgrep's taint mode analysis to help us. So semgrep provides this mode of analysis called taint. And so taint analysis is really about, like, defining certain code patterns that we consider tainted and then tracing the taint through, like, the execution of, like, a module, let's say, through further computations. And so the way that's done in semgrep is we have pattern sources and pattern sinks. So the sources are considered tainted. And basically what semgrep does is anytime I have a tainted value and I do a computation that involves a tainted value, the result of that computation itself becomes tainted. And so semgrep is, like, tracking the taint for us, right, through the code. And it's the rule is going to fire when it turns out that a pattern sink, something that matches one of the sinks, is tainted. So here's a snippet of the rule that comes from GuardDog. You can see one of our pattern sources is the base64 decode, and one of the sinks is the exec call. So we can just work through an example of this kind of by hand, right? So here's like a more elaborate version of that same payload, right? Where not only do we have base64 encoded data, but it's also been encrypted and compressed. So we start here, right? There's our pattern source. It's the base64 decode. And so now, because we've called that a tainted value, right, this encrypted payload variable becomes tainted. And so we've done a computation on it in the decryption, so compressed payload becomes tainted. Again, through the decompression, payload becomes tainted. And so now we have a tainted value in an exec call, which is a sink, so the rule fires. Okay, so really quickly, that's it for semgrep. So just as a quick example of a Yara rule, we would use the Yara and GuardDog to identify malicious indicators rather than code behaviors. So here's like a very simple version of a rule to detect the use of lol bins or living off the land binaries, which are system binaries that would be useful to an attacker. So this is going to fire anytime it detects, like, command.exe or PowerShell.exe, et cetera. And then finally, for an example of a metadata rule, here's the output of the bundled binary rule, which again, it looks for the inclusion of binary executables in the distribution. So you can see you pointed at a package. Here's the finding. It's got, like, the file names and then the SHA-256 hashes, which you can pivot on. And then this gets implemented in Python, right? Very simply, we just look for the magic bytes at the start of the file. Okay, so that's it for GuardDog. And so now Zach is going to take you through some case studies of some real open source software supply chain attacks.
Great. Thank you, Ian. Okay, so Ian gave everyone a lay of the land and how we go and find these pieces of malware. He also gave you examples of real malware we found inside of all these different ecosystems. But we're going to take a step back and look at some real world examples just to make sure that we can really drive home this is a really prevalent problem when it comes to not only these ecosystems but to their target set, which is typically developers. And so to kind of reiterate, this is the threat model that we're concerned about, and we're really focusing on that dependency part there. And so the idea here is that a lot of companies, a lot of firms, they control the build pipeline from developer to source, build, package, and consumer. They don't really have control purely on the outside world, what these registries are doing. And so as you kind of work through all of this and you build all your defenses for this, if there was a compromised dependency that was brought into your build system, this is where the problems start to happen. So attack path one, to reiterate rather what Ian said, these registries, anyone can sign up for it. They're pretty liberal in terms of pushing code. So how do threat actors actually get those packages inside the ecosystem and basically socially engineer their way onto a developer laptop? One recent example of this is a threat group we track as Mutt8694, Datadog, Mutt. We put dog themes to a lot of things. And 8694 is just our clustering method. This specific scenario, about 43 malicious packages were pushed to NPM and PyPI over several days. And these were across many different types of accounts. So it was definitely like a concerted effort to build these accounts out and spread them out to avoid having one account be basically shut down and they couldn't push anything else out. The naming of these different packages suggests they're targeting developers using specific software or building apps against video game APIs. And it basically ended in Stealer malware. And so this is an example of one of the packages that was pushed to NPM, node logic. Pretty straightforward when you run tree over it. It's got one node, JavaScript file, index.js, a package.json file, which kind of helps NPM install that package, and some additional metadata files after that. And so let's run guard-dog over it. So line one, that's us running guard-dog over node logic, and it fired on two rules. The first rule, obfuscation. Again, not necessarily malicious like Ian was talking about, but when you combine that with that post-install script that you see on line 10, that's when things get interesting. We pulled apart the obfuscated payload and we decoded it, and as you can see, with about 24 lines here, this is serving the function of basically loader malware. Loader malware typically gets dropped on these machines, and then it loads additional malware payloads afterwards. Line 2 is what it reached out to. There are binary blobs, executable files hosted on GitHub, and what you see on line 5 and 6 are actual PowerShell payloads that they loaded into this node file and then executed later. And so it went from npm install node logic, and then node logic then used PowerShell to go and retrieve these binaries and then execute them. And so once we ran the analysis on these binaries, we were led to ScoldStealer. ScoldStealer is an open source info stealer, and it does one of my favorite things ever when looking at malware on GitHub. If you look at the top right, it's for educational use only. It turns out every time I see that and then I see it done in a campaign with real victims, it's like, oh, we almost had this person, but then they said it was for educational use only. So they're definitely fine. Written in Golang does several things to kind of collect data off of the victim machine. When they're infected, you can see basically a check-in to your Discord webhook, what type of machine it is, what is it running, IP addresses, users, and then eventually it'll go and basically like a credit card scammer, but for things like crypto wallets, session cookies, and things like that. And so 43 of these packages all resulted in this. And so as you can see, it's a pretty interesting distribution method that's really unique here versus traditional info stealers that go out via email or ads or things like that. So the second attack path, a compromised developer. Those 43 packages maybe got hundreds of installs, hundreds of victims, but what if you went over and went after those developers from NPM and PyPI in the beginning that Ian showed? So hundreds or tens of millions of downloads a week. And so if you can compromise developer and backdoor library, you push that into the ecosystem and then take advantage of that popularity to get your victims. A really, really good example of this, and I was only saying it's really good because it happened after we got accepted and we really got to really dig into this, was Ultralytics. Ultralytics is a machine learning like vision library that, as you can see by the download stats on the right, millions of downloads a week, and it was compromised. And so let's walk through that compromise together. The basic premise was that Ultralytics uses GitHub Actions. They go through the regular build pipelines, and they were issued a malicious pull request with a specially crafted branch name. And that branch name was specifically crafted to exploit a vulnerable GitHub action that did not account for basically what was a shell expansion attack that you see the payload there at the bottom. Once that was ran inside the GitHub action, and that GitHub action is considered trusted, a secondary payload runs, which then dumps process memory and pulled out secrets. And from those secrets, they managed to pull out a deployment token in a cache to PyPI. And they used that to publish inside PyPI and basically backdoor this package with 1.5 million downloads a week. So let's see what GuardDog says. We pulled down Ultralytics 8.3.41. We ran GuardDog over it, and we saw that there was a silent process execution rule that fired. And for those unfamiliar with silent process execution, it's just a way to run a process and redirect all output to /dev/null. And this is typically used for evasion when you're infecting a machine. So I just recently watched Shrek, and I really like the onion analogy, so let's peel this onion back. Line 292 here is where GuardDog caught it. And as you can see, it's doing the silent process execution. But if you look at the function it's in, this was malicious code that was introduced into Ultralytics. A function named saferun, it pulled in a path, and then from that path, it passed the payload, ran that process, and you can see it connect out to connect.consensus.com. Kind of looks like census a little bit. And so let's go look to see where saferun was ran. Peel the onion back, you see saferun. It's running Ultralytics runner as the path. And that's that binary that I just showed, or that executable rather that I just showed on the previous slide. And it's doing some platform checks for Linux and Darwin. This is typically associated with these build pipelines that can run in many different architectures. That runs safe download. And safe download looks interesting because you see some hashes here. So like an ogre, this is an onion. Let's peel it back. Right here, get API. Within the safe download function is where it pulled that actual payload. And you can see that additional curl command that was ran. And so you can kind of see that when it comes to more of these like complicated backdoors with very developed packages, there's a lot more thought that goes into how am I going to backdoor this. It's not just going to be like a smash and grab. They have to actually think about this a little bit more. And so beautiful attack. Amazing. Like this was really, really cool to reverse engineer and see a lot of the research community pile onto this. And in the most disappointing result ever, it ran a crypto miner at the end. So we pulled the binaries, we got the last payload, ran the hash, and I feel like we see this a lot, and it gets really like, it kind of leads us up and then disappoints us. It ran XMRig, which is like a commodity crypto miner, right? And so it just kind of goes to show that like, these types of attacks, it does require a lot of knowledge in order to inject into these types of spaces, but you're not seeing yet that expertise of like a big game hunting type of like ransomware scenario where you have these threat actors really thinking about once this is compromised, what can we do with this access? So let's look at that. Let's look at how nation states and cyber criminals are actually thinking and talking about this more and implementing attacks to achieve their objectives in order to, or rather after these infections. So from the nation state perspective, we have two activity clusters called Tenacious and Stressed Pungsan. Again, Datadog, dog names. It's a DPRK Nexus threat actor that targets developers through their tooling ecosystems. We typically assign dog breeds native to that country for that activity cluster when we're ready to kind of upgrade it into that APT. And Pungsans are really cute. They're from North and South Korea, so we thought it was pretty fitting. And so Datadog Security Research has observed Tenacious and Stressed Pungsan leverage developer platforms like GitHub and GitLab, as well as NPM and PyPI, as well as applying to firms as fake workers in order to get inside developer laptops and eventually company infrastructure. Tenacious Pungsan most closely aligns with Contagious Interview, which is the malicious interview, I'll show in a little bit, and Stressed Pungsan aligns more closely to like what Microsoft calls Moonstone Sleet. The objective, gain access, small and large, exfiltrate secrets in cryptocurrency as much as possible, up to extortion, and then fund national policy objectives. So here's the attack path that we have for Tenacious Pungsan, or Contagious Interview. So the idea here is Tenacious Pungsan uses GitHub and GitLab. They distribute malicious GitHub and GitLab projects, and they target developers to interview for them to perform a coding test on these code sharing platforms, and then those are backdoored specifically. And so what it basically, once that backdoor is ran, a malware family called Beavertail is installed, but we've also observed Beavertail be dropped into those package registry attacks that Ian showed earlier. And so in terms of the malicious interview, developer finds a remote job opportunity on a job posting site, or a fake recruiter reaches out to them and asks them to perform the interview. They're presented a coding challenge and they're urged to complete it. Coding challenge is almost always on a developer platform, and once they complete the coding challenge, they run Beavertail, and then that's the initial access. From a malicious package perspective, Beavertail is loaded directly into that package in Python or Node, kind of similar to what you saw in MUT 8694. And then Stress Pungsan publishes those packages in various accounts on NPM and PyPI, and then that Beavertail infection happens. And so the interesting part here is that we have different vectors with the same outcome, right? And so whether it's the malicious interview or the malicious package at the top, Beavertail execution, initial beachhead, and then it moves into various malware families like Invisible Ferret, Otter Cookie. There seems to be like an animal theme in a lot of these things I'm talking about. Rockrat is another one of them. Gets to late stage infection, reaches out to a command and control server, and then there's additional actions on objective. At least when it comes to Beavertail, it has a couple of different ways it can really dig into a system. And what you see from left to right are the different API endpoints it reaches out to for this command and control server. And this includes everything from downloading additional payloads, either in Python or separate follow-on payloads for Rockrat, as well as uploading and exfiltrating information. So I talked a lot about it. Let me show you one. So this is a contagious interview, malicious interview right here. So a developer is presented this GitHub repo, and they're presented two problems. Fix this problem one, fix this route to make sure the description is saved, and problem two, just implement the CRUD operation. So they get it, they're excited, they're urged to complete it, but this is an astute developer. They have guard dog installed. And so let me run this over this GitHub repo real quick and see if there's anything fishy going on here. Something fired, NPM obfuscation. Now, obfuscation is not necessarily something to be alarmed about, but let's go check it out on check API access. All right, I have a video. I'm going to press play on the video. Let's see what happens. OK, so you presented this. Looks like a regular Node file. You scroll all the way to the right. Boom. That's Beavertail right there. So I'm not going to make you read that because it's kind of hard to see within the video. Press next. OK. So reduce it down, put it in like a normal character width type of screen here. This is the initial loader right here. So it sets up some node exports rather. Then it does a GET request to ipcheck.cloud on port 3963. This is a common port associated with Contagious Interview. Pulls down an additional payload as well as runs eval over it. This is basically like the exec in Node. And as you can see at the right there, the general belief is that V5 is campaign 5 and 504 is a victim ID, but it's not necessarily obvious whether it's like iterated up to that. But you can kind of see them working through it as we see new samples. So I talked a lot about nation state. They definitely do a lot more with the access that they have. So let's take a look at like cyber criminals that really don't tend to drop crypto miners. So Datadog Security Research, we've observed threat actors actively exploring and using the OSS ecosystem as an initial access vector. And so the vector is unique, developers, but the objectives generally remain the same as other distribution mechanisms that they use. So think of info stealers using mouse spam or malicious ads or click fixes or spear phishing. This is just like another notch that they have here. And really, that's just the objective. They want to steal or install info stealer malware and end up on marketplaces. What you see on the right is a post from a user called John Malkovich, who is Evil Proxy. Evil Proxy is a very popular attacker in the middle phishing kit, advertising their services for phishing. And if you look down right at the bottom, they actually have templates for the registries. And so this is kind of like the first time I've seen any type of phishing actors talk about this. And I've been tracking phishing actors since 2015. So let's see what they're talking about a little bit more. Same forum, Exploit.in, Jafar, advertising installs that they're selling off on their botnet. And what's interesting about this one is right there in the red box. Installs are coming through backdoored popular packages. And so when someone asks them about the popular backdoored packages, they generally target and they install malware. And from that malware, they install additional rats, and then they sell those rats, basically, and they sell that access. This one's in Russian, but I promise I won't try to pronounce it. I can sort of read it. But basically what they're asking for is, does anyone have any experience in taking drainers, and crypto drainers are basically things that steal crypto wallets, and are they using that on Ethereum or Solana wallets, and are you doing that with NPM packages or pip packages, as you can see there? So they're definitely thinking about it. And for those that don't know how info stealers work, the basic premise is that once somebody's infected, they go to a marketplace. You can search that marketplace for credentials, and instead of hacking in, you log into the victim infrastructure. And you basically have that impact of making sure that everything leading up to ransomware or other type of infections, or initial access brokers and things like that. And so we wanted to explore this a little bit more, the attack path 2, compromising the developer. And we wanted to run an experiment. Assume that developers download many types of this software that these info stealer teams try to distribute, regardless of vector. Does an info stealer steal the credentials and session cookies from these registries? If it did, does it exfiltrate it? And can we find popular package credentials on these criminal marketplaces? Instead of going after 100 installs a week, can I go to 1 million installs a week? If so, let's measure that impact. And what is it actually going to take in order to do that? So we ran an experiment. We used a vendor of our spy cloud to go and search for metadata on infections for info stealers, and we specifically targeted NPM, PyPI, and other registries. And they were brought back all kinds of just kind of information on what those info stealers stole. We then took all of those victims and we did an API lookup on the various registries for package details. Were they maintainers of package? Basically, did they have merge access to that package? If they were, how many weekly downloads do they have access to? And so this is kind of like that impact statement if I'm phishing and looking for those types of installs. So in 12 months, we found 11,348 separate credentials for just these registries. The way to read this, it's at log scale. So if you look at one on the x-axis, this is the number of credentials exfiltrated. At least one account was exfiltrated for close to 10,000 people at the top there. So it's got like a tail in the beginning, and then it just kind of tails off to 26. So there was at least one infection where they had 26 separate NPM and PyPI accounts on their machine. We then took that and we did an analysis on maintainers. And so the way to read this graph specifically is on the right side, and what you see on the pink line is the number of maintainers. And then at the bottom is how many packages were owned by those maintainers. And then the log scale on the y-axis on the right is how many weekly downloads did you get access to. So you could see some on the left, like at least one person owns like they were a maintainer for one package rather, with maybe 1,000 downloads. And you can kind of read that bin going to the right. And then there's this massive jump of about 3 users that had access to 51 to 100 packages with 22.7 million downloads. And so what that basically means is that if that package was backdoored, you get access to that many installs. And so we did a histogram analysis of it. It basically was one infected user. And the way the stats kind of worked out is they had over 13 packages with 100,000 weekly downloads, and they had 6 packages with over 1 million weekly downloads. And so basically, if this person's credentials were purchased off these criminal marketplaces, then that means that the attacker could get access to all of those downloads. And so what is this? It's big game hunting. And big game hunting was a thing in ransomware you heard a lot several years ago. But the basic premise is that we found hundreds of small fish and one whale. We disclosed all of this information to the registries, and they actioned it, so it made the internet a little bit of a safer place. And really, the attack paths for whales if you want to kind of go down this rabbit hole, is identify those maintainers of those large projects and registries, OSINT or socially engineer their information in PII, check the marketplaces for infections, buy those credentials and backdoor those packages. And unlike SolarWinds, which was 68,000 customers, we now net 22 million installs a week. So this really kind of showcases an ecosystem problem. So what can you do if you have developers and you're helping secure them at your firm or company? A lot of these get their passwords reset and session tokens, but it kind of solves the immediate problem. And so you may not install the malicious package today, but if they're still running on that developer machine, you can't control that machine that's not outside of your company. So it'll just exfiltrate new sessions and new credentials. Like, for example, in one instance, we had one victim with 4 separate info stealers installed. Yeah. So how do we solve this? Endpoint security tooling, amazing. Helps out a lot, obviously, with these like second and third stage downloads. At installation scanning of packages on the machine, like something like GuardDoggy, I would say. A private registry mirror is also used to kind of combat this too. And then, of course, CI/CD scanning of malware can help. And so I kind of gave you the descriptive elements of what you can do. Ian's going to help out with the prescriptive elements and what you can do with what you can do today to help secure your developers.
Thanks, Zach. All right. Yeah, so we just wanted to provide some, a couple ideas, like Zach was saying, for maybe some measures you could take to improve your security on the open source software supply chain. So obviously the first thing we're going to suggest is use GuardDog. So GuardDog is free and open source. You can download it, or you can install it from pip install GuardDog. And you could consider this just like a quick vetting of a package that you're interested in using. Certainly would want to know, right, if it's running any install scripts. And it's good to know a little bit about the package you're going to use before you download it, basically. Of course, GuardDog requires kind of a hands-on approach. You have to interpret the findings, really dig into the details of what they mean. And so if you're interested in a more kind of hands-off approach or a more always-on approach, we have another tool, Datadog Security Research, called Supply Chain Firewall, which basically, with GuardDog, we monitor the open source package ecosystems, and we collect all the malware we find into a public data set. And so Supply Chain Firewall is a way to operationalize that data set. We just put a little software layer between your terminal and the package registries to check that the packages you're installing or would be installing are not malicious. So you can set this up very simply, pip install scfw, and if you can configure your environment correctly, you can funnel all of your pip and npm commands for the moment through the firewall, and it'll just kind of passively check them out. There's also an opportunity here to log all of the successful transactions. So you can start monitoring the use of open source across your infrastructure, let's say. All right, so just kind of a few takeaways for how you might, kind of a roadmap for how you might improve your overall level of open source software supply chain security. So for next week, it would be good to identify high-value targets for these package registry threat actors. What are the sensitive database credentials, the cryptographic keys, et cetera, that are going to interest them. Within 3 months, you should have a comprehensive view of your open source dependencies that have access to these lucrative targets, just sort of kind of tracing the path between these two things. And then it would also be good to pin your dependencies, your open source dependencies, to known good versions to reduce risk from package takeover. So this is just generally a good practice. Don't just use the latest version of a package, because if the latest one gets taken over, that immediately gets pulled into your infrastructure and you're compromised. Not only can you pin it to a particular version, but you can sometimes pin it to particular software artifacts via a cryptographic hash. And then finally, within 6 months, it'd be great to have observability into the way open source is being used across your infrastructure. So basically which developers have tested which packages at which times, what was installed when, that kind of thing. Sort of the kind of thing that Supply Chain Firewall might help you do. All right, well, that's going to do it for us. Thank you for coming to our talk. We love chatting about software supply chain security, so you can find us at our booth here at RSA. There's the number. And then you can also stop by our happy hour today at 5:30 p.m. at De La Rosa. Thank you.
Doing pretty good on time. So we have 10 minutes for a question? Yeah. All right. So if you have any questions, comments, concerns, you have 2 microphones here. We please invite you to come speak into them.
Yeah, I have 2 questions. have you seen a code generator, like an AI code generator, being tricked into using one of these malicious packages?
I think I did hear about this recently.
So I haven't seen them tricked to using it. We have seen malware that has comments from ChatGPT.
Oh yeah.
So they've used it to generate the malware and then push it to the registry. So the comments are a dead giveaway. Like everyone has that like ChatGPT, like if you use it enough, you're like, you just speak a certain way, and then you'll see it in the comments.
Yeah, it's obvious.
Yeah, but I think there was a thing recently that was like using MCP to like coerce the model into generating code that would pull in a malicious dependency or something like that.
Yeah.
Yeah, so something I've heard of, but we haven't looked into it yet, I guess. Could be bad.
Yeah. And the other question is, what can you do with less popular ecosystems, like in Dart, for example, ecosystems that are up and coming and have a lot of new packages? And do you have to manually read the code for everything? Because
Yeah, I mean, so we have support for Golang as well, and we're adding more support for languages. But like, this is kind of like the needs that we saw at Datadog. I mean, we have thousands of engineers. Like, I look at some of our like internal registries, and like, I'm just like blown away by the amount of things that are going in there. So far, what we found is like going down the route of something like GuardDog for threat detection. And then for those ecosystems that you're using that may not have like the same level of visibility, making sure that at least you have like a good defense in depth, and yes, I'm gonna say defense in depth approach to that. You know, secure configuration, you know, private mirrors are also very good when it comes to this.
All right, thank you.
Thanks.
Okay.
I have a question. How does this differentiate for like GitHub security or AWS CI/CD security?
So at least from the GitHub security part, I don't think we're really focused on threats. So you know, we use advanced security as well as, and that really helps out with secrets detection, posture, and things like that. I haven't really seen or used anything from GitHub that does like pure threat detection, and malware detection. And so if it has it, that's great. But this definitely fills the need that we have in terms of like having a developer get popped when they're coding.
And is there any ideas to incorporate it on a SIEM detection or Next Analytics detection, like sending logs to a SIEM?
Well, yeah, so that's kind of this thing with supply chain firewall is there's a lot of opportunity to like block the malicious install, and that's kind of what it's for. But then you could use it just as easily to kind of enforce like policies around open source and to kind of like log who's using what at which times, and so now you have observability into like what all of your developers are, what packages they're playing with basically on their development laptops.
At least what we've implemented, we have developers now installing supply chain firewall, and if we get a true positive, it generates a similar and gets sent to our security team.
Thanks.
Thank you.
Are there any initiatives that have been put forward from the registries to help combat this issue, to get it earlier on in the process rather than these like downloaded tools?
So I'm happy to answer.
Go for it.
Okay. The answer is yes. The problem that they have is they have to balance usability and the ease of signing up and affecting those workflows with security. So we work very closely with PyPI. And they're awesome to work with. They built basically an endpoint for vetted researchers to submit malware. But again, like PyPI, it's a nonprofit at the end of the day. So as much as they're trying to invest in it, they always have to manage resources. On the NPM side, same thing, good researchers, good Intel team. They have that backing from GitHub and Microsoft. But it's all about making sure they can manage the balance between usability and security in this aspect.
Yeah, I think I would just add that like they're both of those ecosystems are really proactive about malware reports, like getting stuff taken down quickly. And then they also, especially NPM, is very good about replacing the malicious package with a security placeholder so that people don't get reinfected, or people who didn't update don't get infected. But yeah, just it's kind of at the point of upload that it's kind of anything goes. Like they're very liberal with what they allow you to upload. So I guess not having the first thing, having only the second thing and not the first thing would be horrible, right? And so this this kind of reactive approach is like the one they've taken. It's, yeah.
Okay, any other questions? All right.
Great. Well, thanks again,
Thank you all.
everybody. Enjoy RSA.